Hello everyone, it's Mr. Wolfe, and in this video I'm going to be going over number 1 of page 26 of your Unit 2 packet. So let's go over this. You're lifting a box with an upward force. I'm not even going to worry about numbers yet. Let's just draw our FBD. So here's my object. There's an upward force, so force push or pull. Right? And then there's the force of gravity on the box. We also know that because we're just in general on Earth. However, I am going to notice kind of the numbers here. This pull force is bigger than my force of gravity, so I'm going to draw my force of gravity just being less. I might go through my other forces. Are there any ropes? No, not in this scenario. We're used to seeing a normal force, but it doesn't say that it's in contact with the surface, and I don't think it would be because you're lifting up the box. So at this point, it's above the ground, so no normal force. So these are our forces right here. There's no force of friction either because we're not sliding against a surface in any way. So my net force in the x direction, there's no forces in my x direction, so it's just 0 newtons. My y direction, it's always your positive forces minus your negative forces. So in this case, my force push is going up, minus my force is going down, minus the force of gravity. Right? And then what we could do is we could start to draw some arrows here. Right? In this case, just visually, without even the numbers, I know that my net force is going upwards because it's bigger than my force of gravity. So net force is going up. And just remember from Newton's second law, which is our equation that we're going to use in a second, acceleration is equal to F net divided by mass. Whatever your net force ends up being, your acceleration ends up being the exact same direction. So the net force causes the acceleration to also be going up. And if I'm lifting up a box, it was probably at rest before, so now I'm lifting it up with the net force going upwards, so my velocity is also going to be going up this way as well, and increasing speed going up. All right, so I've kind of set up my situation. Now I want to calculate the acceleration of my box. So here's the equation I'm going to use. I know at the end of the day I want to find acceleration. And let's see what are the variables we have. I have mass is 7.7 kilograms. Again, the unit's going to be really helpful, kilograms. It also just says mass. So 7.7 kilograms. And then I also need to know my net force. But looking at the problem, it says nothing about a net force. So what I have to do is I have to figure out a way to find this net force. Luckily, I've kind of done a lot of the work right here, right? I know that my F net Y right here. So I'm going to say, okay, well, F net Y. I know I have to use this, by the way, because we're pulling up the box, so that's going vertically, and then also there's no forces in my x direction. So I know it has to be in the y direction. So force push minus the force of gravity, F net y. 125 newtons is my force pull, minus the force of gravity, 75 newtons. So my F net y ends up being 50 newtons. And it's positive, which kind of goes along with this idea of pushing up in this case, my net force going up. So I'm going to take this number, and I'm going to just plug it into my net force. So now it's 50 divided by 7.7, my mass, and I'm going to get an acceleration of 6.5 meters per second squared. Now, since this is a positive number, I could either put a positive here, I could have it going up, right? Which again agrees with what I have drawn here conceptually. This is how I would solve this problem.